Good morning, everyone. Just setting our offset for today seems to be pretty bad. A-E-I-O-U. Yeah, I think that'll be good enough. Our lecture shall begin at 9:30 as is usual. Oop, I am muted. Okay, there we go. Thank you very much. Yep. Alright. So, yes. With respect to questions about the format for doing the assignments and all of those sorts of things, if you have questions of that nature, please post something to the Piazza forums. If you take a look at Piazza, we can reply to the things that you're saying in a more detailed form. Yeah, a little bit. We can reply in a more detailed form, and that might be more useful to you than me just saying something on the stream. So I see a lot of people have noticed that I shaved, I cleared out my cheek forest, so to speak. Yes. I suppose if my face is so prominently displayed, that is a thing that you might notice. Anyway, so with respect to that, if you will notice that assignment 1 is due at the end of the week, that would be good. If you try your hand at assignment 1, I hope that it should be reasonably intuitive and not terribly difficult. So there you go. Well, I will. Maybe we can get the subscriber count up there. Hey, where his is. Anyway. So, we were talking. Oh my goodness, are we behind? Bloop. This is topic 2. Yes. Let me think. Where were we on topic 2? We did this one. I remember that one. We did that one. Remember that one. Gotta get the Zoom fit page. Thank you. There we go. It's terrible that fit page doesn't also align page. There we go. Multiple assignment. Yes. Yes, I think. Yeah, we didn't do comments. So let's start here. So, let's see. Good. All right. Yes, let's get on with it then. So in Python, I'm just going to have, that's a lot of, let me open up a new tab there. I'm just going to open up a Python interpreter here, which, can I, yeah, that'll be fine. I might do some code demonstration type stuff in that interpreter while this presentation is going on, this lecture. So, anyway, let's talk about assignment. We were covering assignment statements previously. Assignment statements, for those of you who are, for those of you who skipped all of the lectures last week, assignment statements are the manner in which you assign values to variables. Variables being pieces of memory that have been set aside to hold particular, whatever value you see fit to use them for. The assignment statement is the actual mechanism by which you assign something to the variable. So, for example, if we assign the value of 4 to the variable a, from that point forward in the code, the variable a will have the value of 4 until such time as that value is changed again. So, if we say, for example, x is equal to 7, and we ask for the value of x, it gives it. So, in the interpreter, just typing the name of a variable is shorthand for doing the whole print statement. It's the same thing. So, yes. So the way to think about this is a becomes 4. The thing about variables, when we're talking about variables in a computing context, is that variables always, always, always have a concrete value. That's because they are mapped to actual physical hardware. They're mapped to actual regions of your computer's memory system. So, it is impossible for a variable not to have a concrete value. That concrete value may or may not be meaningful. For example, sometimes in certain languages, when you initialize data, when you set out a certain region of memory and say, this memory is for that variable, if you don't initialize that, then it will be filled with whatever values were there prior to you declaring the memory, which we call garbage data. Data only means things in context. So if there's no context for the data is meaningless. The context provides the meaning. That's why we call it junk or garbage data, because we can't extract any meaning from it. But variables in an algebraic sense, which is hopefully the context in which you have known variables so far, a variable in an algebraic context can be any number of different values. The value of the variable is constrained by the algebraic equations that are, in which the variable is included. However, in this case, variables always have a concrete value, and this is how you change it. Let me just see if we have any questions. Oh, thank you, Moonstar, for asking questions. Yes, thank you. Cool. So, good. Later on, we'll see double equal sign. That's equality evaluation. That's a test to see if A and B are the same thing. That is a different thing. Confusing double equals with single equals is a syntax error. Generally speaking, people confuse this one for that one and not the other way around, but, that's neither here nor there. So, in Python, we can also perform multiple assignment operations at the same time. There are actually a couple of ways of doing this. So, if we say x comma y is equal to 5 comma 6, and we ask for x, and we ask for y, there you go. It performs two operations at the same time. Another way of doing this is by using the semicolon. Generally speaking, in language... Oh, I should do something else so that it actually shows up, eh? In languages other than Python, the semicolon operator is usually used to denote the end of a line. It's the end of pardon me, the end of line character. Because basically one of the observations that the people who put together the Python programming language made was that, generally speaking, you don't need a semicolon operator dedicated for the purpose of ending a line, because you end a line with the return key, right? That's the new line character in, very technically speaking. So you don't actually, it's superfluous syntax. And one of the things that Python attempts to do, sort of philosophically as a language, is reduce the amount of superfluous syntax that exists. Now, people such as myself, who know what we're talking about, would say things like, you're not actually reducing the amount of semantic meaning that needs to be expressed by the user. All you're doing is moving it around and loading different parts of the program with different semantic meanings. For example, in Python, indentation is everything. Indentation tells you what code is inside which code blocks. What Python did was they took conventions that existed in other programming languages and imbued those with the semantic significance that they had in those other languages as a way of making the code more readable, and were able to dispense with a certain amount of the actual characters that were used to, represent that sort of thing. So, an interesting thing... Oh. So, swapping operations are a important thing to talk about as well. So, generally speaking, and this is important, the swap operation is a good example of how variables work. If you understand this, then you have a pretty good concept of how memory works, which is a good thing. So let's imagine we had two variables, x and y, the value of x being 8 and the value of y being 9. Let's imagine that for whatever reason, it was our desire that x should have the value that's in y and y should have the value that's in x. So we want to take the values and swap them between these two pieces of memory. Sure. So one might say, well, let's make x into y and let's make y into x. So what do we get as a result of that? Well, x has the value that y used to have. That's good, that's correct. Y has the value that y used to have. This is not correct. That is, we have goofed up. So what happens is in this line, when you are assigning the value of y to the variable x, you are overwriting the contents of x. That content, once overwritten, cannot be recovered. So you've essentially deleted half of the swap operation, half of the stuff that the swap operation was supposed to have. So in computing, the thing that you have to do if you want to perform a swap is that you have to use another variable to hold the value that used to be in x temporarily, so that it can then be reassigned back to y. So let's start fresh. X comma y is equal to 1 comma 2. X is 1, y is 2. Let's say temp is equal to x is equal to y is equal to temp. Then x is equal to 2 and y is equal to 1. We have actually performed our swapping operation. This is good. So, Python, of course, gives us shorthand for this as well. Python loves giving people shorthand for things. So if you just do x comma y is equal to y comma x, it performs the same sort of swapping operation without having to manually designate a temporary swapping variable. It's not that the temporary swapping variable isn't being assigned. It's just Python is sufficiently intelligent to realize that it's going to require one, and it just provides one automatically and hides that information from you. So there we go. Questions? Yes. Good. So what about temp? That's a good question. So temp is just kind of there now. In a lot of languages, you can deallocate variables. However, generally speaking, the amount of computer memory that's assigned to variables, especially small ones like this, that's not considered to be a that's not considered to be a load on the CPU system. Like, if you think about it, the variable that we just assigned is like 64 bits, or 32 bits, depending on your system. The total amount of memory that you would have in your system would be something like, 248 gigabytes. A gigabyte is 1 billion, well, it's not quite. It's kind of interesting. 1 kilobyte is actually 1024 bytes. So it's kind of funny because everything has to be base 2. But at any rate, it's like, if you imagine you could assign, 500 million, or 100 million, or some large number of that type of variable before the computer starts complaining about running out of memory, it's generally considered not a big enough issue to worry about. The temp variable will be deallocated, that's the term for it, deallocated, when the program terminates. So for me, running this program inside of the interpreter, when I close the interpreter, the temporary variable and x and y and any other variables that have been allocated inside of the interpreter session will be deallocated and destroyed. Destroyed ultimately. So hopefully that's an answer to your question. Am I using the Anaconda prompt, or am I using... So I'm using a Linux operating system. So inside of Linux, you can open up it's called a bash shell. And if you scroll up here, all I did was I invoked Python 3. So Python has its own command line interpreter that comes with it by default. If you just open up Python 3, then you get this. You can also run this in Windows PowerShell. And I believe packaged in the Anaconda distribution for Windows, there is a link. There's an actual link that you can link up to your start menu for the Python 3 interpreter via Windows PowerShell. So there you go. So, naming variables. This is more a stylistic thing than any actual hard requirement. To try to use variable names that help you remember what the role is that variable plays in your code. So, rather than name everything A, B, and C, X, Y, or Z, name things like pi, radius, area. Variable names that describe what the function of the variable is. It'll make your code a lot more readable. Incidentally, you don't actually have to allocate a variable to hold the value of pi. You can get the value of pi from the math library. Import math. There we go. Cool. I see that they are keeping you busy, eh? So, let's talk about comments. You can add explanatory comments to your source code that won't get executed. For this, you kind of do need a file. So, get it my program.py. So this is get-it, which is just a basic text editor. So if you have a, Python function, let's just make it a hello world. Come on, jeez. You can add comments to this using the #, hashtag character. Its technical term is octothorpe. This symbol is called octothorpe. So if you type stuff in here, that is not code. What happens when you give this script into the Python interpreter in order to be executed, anything that's inside of a comment area is removed before the code is executed. However, it's saved in the file. So if you want to leave yourself little notes about how your program actually works, then the way that you do that is inside of a comment. That's why they call them comments. So this is a comment. Comments can occur at the ends of lines. However, if you can't put a comment before, basically the comment symbol says the rest of this line isn't code. Some programming languages have multi-line comments, but Python does not. Well, not yet anyway. We'll see things that look like multi-line comments, but they're a little bit different. So a common usage of comments is to be able to deactivate segments of your code. So if I put some code that I've written inside of a comment region, that code is disabled, which can be very useful for our testing purposes. So, good source code includes lots of comments to help the reader understand your code. Always comment your code. Comment your code or else. Here's an example. So, formula to calculate the area of a rectangle, width, length of one side of the rectangle, length of the other side of the rectangle, etc., etc. Generally speaking, the more verbose your programming code is, the more understandable it will be to people who are not you, and to you at a future date. The thing is, generally speaking, code that you write is stored in your short-term memory. And I'm not talking about computer memory, I'm talking about biological memory. Your short-term memory you will not be able to remember much about what's going on in any piece of code that you've written in 2 weeks' time. If you haven't left yourself comments about what it was that you were doing, you basically have to piece together what you were doing from the code itself, and this can be very difficult because code is written in code. It is encoded. So, always comment stuff. Commenting is the best thing. Yes. So I will mention that, yeah. So technically speaking, there's another way of commenting, which we are going to get into when we talk about functions. But if we have a function, which does stuff, you can also add a comment to it, which, if you use 3 quotation marks, this is a docstring. So it's a little bit complicated, but essentially this is a way of documenting functions that you write. If Python has a help function, which I'll demonstrate to you now. If you type help and then you put in the name of a function, like, for example, print, there you go, it gives you a bunch of documentation about what print is, what it expects, what you can put it in it, etc., etc., what the inputs are, what the outputs are. What this is doing is it's searching for the docstring for the printf function, and it's displaying it to you. So if I were to execute the script in this file and I was to call help on add, it would display whatever I've written here as the docstring. So there you go. Badoop, badoop, badoop. There we go. So let's talk about Booleans. So bool is another scalar object type. So this is a data type with 2 possible values. A Boolean only has 2 values. It's either true or it's false. There's no in-between stuff. True and false, generally speaking, map to 1 and 0 in terms of binary code, although it's a little bit more complicated than that under the hood. Booleans can be very useful. So, at least, although you may not use Boolean variables a whole heck of a lot, although they can be very useful, the Boolean type is extremely useful because you can't really understand what a comparator is doing unless you understand what a Boolean is. But yeah, it's just true or false. Those are the 2 values. Those are the 2 allowable values. So comparators will compare 2 ints or floats. They can actually operate on more than just ints and floats, and they will yield a Boolean value. So double equals sign, that's a test for equality. Are A and B the same value? A is less than or equal to B, A is less than B, A is greater than or equal to B, A is greater than B, and A is not equal to B. So that's a test for inequality. So let's say we had X and Y. Let's say X was 1. So does X equal Y? False. Is X greater than Y? False. Is X less than or equal to Y? Yes. Is X not equal to Y? That is correct. So these are going to be super, super useful when we start talking about higher level constructs like if statements and loops. In order to have different code, in order to have different pieces of code execute under different conditions, you need some mechanism for describing what different conditions means. Excuse me. So, using something like an if statement, you can have certain code execute if x and y are the same, and you can have other code execute if y is greater than x, etc., etc., which we'll get into that. But these are the building blocks for comparisons that you will need to know how to use if you want to use branching statements and looping statements. Lots of questions. Thank you, Mark, for looking after all of these questions. Some of them are very off topic. Classes are not a thing that we're going to talk about until week 8. So please don't get too far ahead of the lecture material. So let's talk about equality versus assignment. We mentioned this before, but so be careful about the difference between 1 equals sign and 2. 1 equals sign is assignment. That actually changes the state of the variable. Double equal sign is comparison. Although I have only used if I've only used variables here, it is totally possible to say something like x is equal to 16. You can use literals in there. You can even use 2 literals in there. Is 7 equal to 16? No. Is it ever going to be? Probably no. Could you just have written false? Yes. So 1 equal sign means assignment. It is a statement or an instruction. It updates the state. Double equals means equality. It is a test. It checks. It evaluates to either true or false. So when we say evaluate, what we mean is if we have an expression and we calculate the value of that expression, that's called evaluating. The contents of the variable a are not changed by an equality test. So just, it's like a rookie mistake or a pitfall for beginners to misunderstand the difference between 1 equal sign and 2. So let's talk about functions. A function is a way of grouping together a sequence of operations under a common name so that we can refer to it multiple times later. The idea is similar to mathematical functions such as cosine, exponentiation, logarithms, etc. However, it's a little bit different. Just like variables are a little bit different in computing versus in algebra, functions are a little bit different in computing as opposed to algebra. The correct way to think of a function is as a subprogram. These are you can. It's not technically correct, but you can think of it as a subroutine. You may have heard of the term subroutine. A subroutine is just a function that doesn't return anything. So with functions, you have inputs and you have outputs. That's probably going to be on the next slide. I'm probably going after slides I haven't covered yet. Yes! Okay, there we go. So this is the syntax for declaring a function. In order to declare a function in Python, you must use the def keyword. The def keyword must be followed by the name of the function. The same rules apply for naming functions as for variables. You must then have an open brace, a closed brace, and a list of inputs. 0 or more variable names, which will be assigned to whatever values the function caller provides. Then you have a colon. Everything inside of the function must be indented by 1 step. You then have a bunch of statements which constitute the body of the function. And then you have the return statement, and then you return whatever the value what you wish to return is. So let's write some functions. So let's say I want to write a function that adds 3 numbers. We will call those numbers x, y, and z. Sorry, my dishwasher's making weird noise. So, this is a very simple function. We don't even really need any statements between this and the return statement. We can just return x plus y plus z. And that is a function. We can even do these sorts of things right into the interpreter in Python. So def add 3 is x, y, z. The thing about programming in the interpreter, however, is that you have to get it right the first time, which means that it's not a good solution for writing an assignment. Z. There we go. Now, add 3 is defined as a function. If we wish to use or invoke the function that we've just written, we supply it with values like that. These are called arguments. Arguments do not have to be literals. You can add 3 x, y, 2. You can even have compound expressions inside of these arguments. The arguments are expressions in the regular sense. So you can do whatever you like with them with respect to building an expression inside of an argument. So that's how you define and use a function. Should be relatively straightforward, yeah? So emojis are... The problem with emojis as variable names is that they often contain special characters. As if you're doing stuff like the Lenny face here, like many of those, perhaps all of, I think all of those characters would be ineligible as they are not correct characters with respect to naming conventions. However, something like XD, that would be a XD would be a valid variable name. And because everything's being auto-graded, we don't actually care what you name your variables. Like, it doesn't make one slightest whiff of difference to us. It's mostly for your benefit that you should name things correctly. Good. So, there we go. So for another example, if we wish to define the Pythagorean theorem, we can do so as such. Def Pythagoras x, y, colon, indentation, z is equal to x to the second power plus y squared. Return z to the power of 0.5. That is Python shorthand for square root. So Pythagoras 3, 4 is 5. There you go. There is another way to use square root in Python. You don't have to do that, but you do have to import the math library. And for whatever reason, the abbreviation that's used pretty much universally across programming languages for the square root is sqrt. So we squirt rather than square root. Oh, hello. Maybe I'm wrong about that. Maybe they fixed it. Maybe it's math.square root. Yeah, there we go. I'm just not addressing things correctly. So, math.square root 25 is also 5. So you can see that this is fewer characters, and you don't have to import the math library. So that's generally why people use it do square roots that way in Python. It's just faster. So So here's another thing. What happens when we type the following code? A is 4, B is 5, 3 times A plus B. Well, let's try it. A is 4, B is 5, 3 times A plus B. Uh-oh, we got an error. Int object is not callable. So this is the syntax for calling a function. If you have something, this means you're passing it an argument. This is a big difference between algebra and computing. In order to perform this operation, you have to use the multiplication sign. In algebra, the multiplication sign is implicit. You don't have to explicitly write it. It is just there by default. It is assumed to be there. However, in computation, we assume this means something else. We assume this is a function call. Since 3 is not a thing that takes arguments, it's just a literal, that's why we get this error here. So, don't imagine that that means anything with respect to multiplication. Generally speaking, these things, like, it's not a huge problem to get an error, right? Just take the feedback and fix it, you know? It's not like you're a terrible person because you didn't program correctly. That's not how life works. Which has the highest priorities? So with respect to operators, operators generally speaking work on bedmass rules. So because this is in brackets, it will be computed first and then the multiplication would execute. However, if you were to remove the brackets, that would be 3 times 4 plus 5 rather than 3 times 4 plus 5. So bedmass rules apply. So let's talk about more complicated stuff. We've talked about the easy stuff. Let's start talking about the complicated stuff. Tuples. Tuples are they are collections of objects. They are linearized collections of objects. So a tuple, let's say T, if you 1, 2, 3, if you have these round braces, followed inside of the round braces you have a bunch of stuff and there are commas separating them, that is a tuple. It's a compound variable. You can get at the various elements inside of it using addressing. However, it's a little bit different in programming. Normally, you might think this is the first one, that's the second one, that's the third one. So the first one, T1, should be this one, but no, it comes out this one. That's because in computing, and there are reasons for this, but, you know, they're a little complicated. In computing, you start counting from 0. So T0 is the first element. T1 is the second element. T2 is the third element. That's how addressing works. You kind of just have to get used to it. In Python, the elements of a tuple can be of diverse data types. So if I want to put a fish in here, then T at 2 would be fish. There we go. You can put any number of items that you want into a tuple. So if you wanted 100,000 things, you could put 100,000 things into your tuple. The things that you put in, things stay in the order that you put them in. So the 32nd element will be consistently the 32nd element. Oh, and incidentally, you can reassign the values using other data types, not tuples. Tuples, once created, are fixed. They are known as static data types, and that's a thing we're going to get into. You can assign a tuple to a variable as well. That is what I've been doing here. So yeah, tuples. Lists are something else. A list, so there are a number of data structures that are similar to tuples that have various names in the realm of computing. Tuple, list, array, dictionaries, I guess you could consider those as well. And we also have sets in Python. For those of you who know other languages, tuples are more or less similar to arrays, but they are static. So assignment is not well, no, they're more like strings. They're more like strings in something like C. Anyway, so here are some operations that you can perform on tuples. As I already demonstrated, using square braces gives you the some particular indexed element. This is called indexing, because this is the index. That's why I is used. It's because it's the index. If you wish to concatenate is probably a new word for you guys. Concatenation takes two things and sticks them together. So if we had T and U, let's say U is, say that again. Oop. Punk. Notice that this is the comma character and not separating an element because it's inside of these quotes. So T plus U is 1, 2, fish, say that again, punk. The length, len, takes the length of a tuple. So len, and this is going to be a one that you guys use quite a lot. The length of T is 3. The length of U is 4. The length of T plus U is 7. This is a cool one. This is one that's reasonably unique to Python. The operation is not unique to Python, but binding it to the word in, as far as I know, is more or less unique to Python. So if we wanted to check to see if 2 is in T, that's that easy. It's a search operation. Is 7 in T? No. Is 7 not in T? That's correct. There you go. So, here are some interesting observations about tuples. Tuples are immutable. We can't change one entry of a tuple. We can use assignment this way, but not the other way around. Like, say x is equal to t at 1, x is 2. However, if we modify x, t1 has not changed. They don't link the data like that. Again, it's important to know that these types of data structures are zero indexed. Yeah, and if we were to use assignment in the other direction, as demonstrated, that is an error. There we go. Another way of saying immutable is to say static. We're going to get into the idea of mutability and immutability to quite a considerable degree in the week 4 slides, or the topic 4 slides, pardon me, because we will be talking about all of the data structures. So let's also talk about strings while we're at it. We've seen strings a few times. Hello world is a string. However, you can actually also assign strings to variables. So, derp. There we go. String literals are strings that you type directly into your source code. In this case, these things that are enclosed in quotes, these are string literals. The string literals can be wrapped either in single or double quotation marks. So if I were to exchange these with single quotes, that is semantically the exact same thing. That is the same thing precisely. The interesting thing about... I have a little bit of a tangent to go on, because, this is another way in which Python is very different to many other of the programming languages that you may find yourself in need of, particularly if you're in the comp sci stream. People who aren't in comp sci, you guys can probably survive on Python for most of the things that you will need to do. Although, it's a good Python programming does generalize reasonably well across a large number of programming languages. But you comp sci guys, you're going to have to learn languages other than Python for sure. So it should be noted, in most programming languages, double quotes means strings, and single quotes means an individual character. So in many programming languages, a string is a compound data type, but a single character from a string, that's not a compound data type. That's just a regular data type, like an integer or a float. So it's like saying so Python kind of confuses or blurs the distinction between a compound data type and a singular entity, shall we say. And that's fine for Python. They're fine with it. But if you were to try to take this to Java, for instance, you would be in for a world of hurt, and you wouldn't know why your program didn't work. But incidentally, characters as a data type do not formally exist inside of Python. They kind of do, but according to Python, characters do not exist. If you want a character, then you use a string that contains one character, and that is a character in Python. It's not like, again, all of the sort of bookkeeping stuff to make that, all of the bookkeeping stuff that allows you to have this sort of fuzziness in your concept of what a string versus a character is, all of that is provided to you by Python. Python is doing work in the back end so that you don't have to worry about it. But there is a difference. Yeah, Haskell does these differently, so. There we go. Boop. So the question is, one question is, if we have our strings delimited is the proper term for it. If our strings are delimited by either single quotes or double quotes, how is it that we actually put single quotes or double quotes into the string that we wish to print, or the string that we wish to work with? And so the answer to that is that if you're using one or the other, then you can just use the one that you're not using. So the rules, right? So the problem is, if you use these single quotes like this, the computer doesn't know when the string is supposed to be ending and when it's supposed to be beginning. It can't read your mind, right? Computers cannot read your mind. So it thinks you mean this is a string, this is a variable or an operator or something, and this is an empty string on the end of it. And that's incorrect. However, if you use the opposite of the quotes that you have on the outside, then it works just fine. And this also works for going from double to single quotes. Oh, there you go. So if you're in a situation where you need both single and double quotes, there is a way of representing quotes without... and this is like the way that quotes are normally done in other programming languages, using, double quotes only mean strings. In order to insert the quote character, we have this slash character. This is called the escape character. This allows you to express a bunch of different types of characters that are normally not. And I know the lecture is over, but just give me a minute to finish this idea, because it's interesting where it goes. The escape character allows you to express things that are characters that are not necessarily things that are on your keyboard. In this case, it is something that's on your keyboard, but if you have /n, that is actually what's called the new line character. So it actually puts it inserts a line break. And if you have /t, that inserts tab characters. So that's cool. Anyway, I think that's as much damage as we can do today. Thank you very much for your time and attention, folks. I'll just wrap up whatever questions Mark didn't get to, and then we'll call it a day. Mark has been busy. So this is not quite the same thing, actually. So paste. If you were to... So in a lot of programming languages, this is roughly how strings are expressed. Strings are an array of characters. However, in Python, because there's no difference between a character and a string, this is actually a list of strings. So I think you've got a concat function. Yeah? No? All right. It's probably like in some library somewhere, but you can concatenate all of the elements of that to form the string. There we go. Heh. Are you allowed to use lists in assignments? Yes. Oh, Rimby. I don't know where Rimby is today. She's probably sleeping somewhere. Someday I'll show you the other cat. He's huge. You're allowed to use anything if it's not plagiarism. That's true, actually. So, I know some of you have classes to get to, but my essential philosophy with respect to how it is that you guys are to program, I am not interested in you guys learning that, like, how to say, there's a bad way of learning how to program and a good way of learning how to program. The bad way of learning how to program is like, I have seen this problem or this type of problem before, and I am going to apply this particular methodology to it every time. This is like static and inflexible. The way that you want to be able to program is to be able to actually look at the problem, decompose it into an algorithm, and write that algorithm. Now, in order to learn how to do that, you're going to make mistakes when you're first starting up. That's why we're not interested in you guys following some particular form and learning, oh, this is how you solve this problem. You guys have to learn problem solving. And in order to learn problem solving, you have to be given the freedom to be able to come up with your own solutions to problems. We want you guys to be coming up with your own solutions to the problems. So we're not checking for particular form, or, oh, you didn't name your variable this, so it's wrong, and you didn't use a loop like this, so it's wrong. That's not how we mark in this class. We mark on results. So if your algorithm calculates the question correctly, then it is correct, regardless of how it's written. That's how we're marking here. So, yes. Okay, I'm gonna go grab the big cat, and if you guys want to see him, and once I show you the big cat, then that'll be the end of the stream. I'll be right back. We will be explaining the for loop in like the upcoming lectures. Oh, there he is. Hello. Hi. Hello, Mars. Oh, you got kisses? He's got kisses. Very cute. This is Mars. He is half Maine Coon, half Bengal. He is a huge cat. He also likes giving kisses. He just woke up. But, like, look at the size of this guy, eh? This is Martin. Yeah, he a thick boy. Smoosh, smoosh. Yeah. So, he's an awesome cat. I love his mane. His mane is my favorite part of his physical features, aside from his size. He is a male cat. He is a big boy. There we go. Anyway, there we go. Cool. Anyway, I think that's enough. Thanks for the help, Mark. We were a little bit behind in this class, so it's good for us to be able to make some friggin', yeah, Maine Coons are like the best cat. Yeah, like, in terms of personality, like, they're kind of similar to dogs in terms of personality, but it's kind of like the lovable nature of the Maine Coon crossed with the very big intelligence of the Bengal breed. Like, Bengals are a very intelligent cat, and so he opens doors. That's it. Like, he will just, if you are in a room and he wants into the room, he will just open the door and come into the room. Of course, it doesn't help that we have like the handle style doorknobs, but anyway, I should probably stop yammering on so you guys can get to the next. Oh, Scottish Folds are so cute. So cute. Oh. All right, anyway. Have a nice day. Take her easy.